Hello everyone, welcome back to Integration Ninjas. In today's tutorial, we will be learning how to deploy a Spring Boot application to AWS EC2 instance using the power of GitLab CI. This video is perfect for developers looking to streamline their deployment process and leverage the power of continuous integration and continuous deployment. Let's dive in. GitLab CI, let's understand first what is GitLab CI and its importance also. The GitLab CI means continuous integration is an integral part of GitLab, a comprehensive DevOps lifecycle tool. GitLab CI enables developers to automate the testing, integration, and deployment of their code, ensuring a smoother and more reliable development process. By using GitLab CI, you can just automate testing and deployment. You can enhance the collaboration within your team and speed up the development because of the CI/CD features, and you can also improve the code quality also. So yeah, so these are the thing for by integrating this, you will be able to easily deploy your Spring Boot applications leveraging the scalability and reliability of AWS services. So let's see how we are going to set up this. So the setup will be very simple. We'll have a simple Spring Boot application where we will have that will be like hosted on the GitLab repository. Once a user will commit to a specific branch, we are going to trigger a pipeline. So that pipeline will have couple of jobs, one will couple of stages. We can say in GitLab we have stages, and those stages will have multiple jobs. So those stages will have build and deploy stage. Build stage will have build job, deploy stage will have deploy job. So both will do their respective work. So in build job, we'll just focus on creating the Docker image. We are going to create a Docker image of our Spring Boot application. And in the deploy job, we are going to deploy it on AWS EC2 instance. How we'll do that? We are going to configure a self-hosted runner on the AWS EC2. Okay, there we are pull the image and then we'll run the Docker Spring Boot app as in Docker container. All right, so let's go to the hands-on practices. Okay, so let's first see like how our Spring Boot application will look like. It will look like this. Let me just run this. Okay, we can just run this Spring Boot application here. This is the main file here. We can just run it from here. Once it will be started, it will be running on the port 8080. So the response will look like Integration Ninjas, just name and the email. There is nothing else. We are just running the simple API. Okay, so this is our Spring Boot application. So now what we are going to do, we can see first this is the hosted on the GitLab, and we are working on the deploy to EC2 branch. Okay, let's do one more thing. Let's create our EC2 instance also, then we will just do everything. So let's create on the launch instance here, launch instance, and we can select any of this available. You can use any of the image. I'm just going to use the Ubuntu here as the machine image, and the free tier one I will just select for now for this tutorial. And you can select a key pair login to like access to your EC2 instance. Okay, and that's it. Like you can just configure it. You can just name it also. I will just name it as Spring Boot example. Okay, and then I will just launch the instance. All right, so that's it. We have created a EC2 instance. Now here what we have to do more is we need to create a runner also, GitLab runner also on the AWS side, right? So how to do that? Okay, let's go to the settings and then the CI/CD. Let's go to settings and then CI/CD, and then if you see here, we need to open the runners section. We need to expand this, and these are some of the assigned project runners. We can just remove this and we can create a new one, and these are the runners provided by the GitLab, so we are going to use them as well, and we are going to create our own as well. Okay, So let's see how to create a self-managed runner. So let's click on the new project runner, and we'll just name it as EC2 runner and just click on the create runner. Here you can select the platform because we are running on the AWS Linux machine. Then we are going to select the Linux one, and then we need to download and install the runner. So first we need to download the runner. We will just copy these things. For that we need to log in into the AWS instance. So let's go to our instance created. Okay, which one is the one? Okay, this is the one, this is the another one. So let me just delete this. This is of no use. We'll just terminate this, but we are going to use this since all this instance is running. And let's click on the connect one. I will just connect it from the browser. You can log in via putty, or you can just log in from the terminal also. Let me just log in from the browser only. I will just select connect. Here I need to install Docker because we will just running the Docker image here. So we'll just set up the Docker here on this machine, then we will just write up all those codes. So for that we need to run a command. I will share in the video description. This will download and set up the Docker here. So we'll just do this process. It will be better if we set up everything first, then we just write everything, because later if we do, it will be like very clutchy. Okay, so Docker is being installed here. Now we can just see Docker info. Everything is there, and now we'll just give some of the permissions. We need to install the GitLab runner first, so let's do this right away. Okay, it's done. And now what we need to do is we need to register the runner here. Copy and paste the following command into your command line to register the runner. So we'll just register the runner on our EC2 machine. Okay, that's it. Enter the name of the runner. I will just name it as EC2-runner, and we'll select the executor as shell. Okay, and that's it. The configuration is saved. And what else we need to do? We need to run this command. Okay, so our runner will be up and running. Okay, so we can see you have registered runner. We can just view the runners. Yeah, we can see the runner is up and running. So now let's go to our code base and let's create a Dockerfile now. Let's click on file and then Dockerfile. So here we are going to use a multi-stage build. Like first we'll use a Maven image, then we are going to use OpenJDK. So it will be better like if we use the multi-stage builds. So that will contain the minimal routine dependency and the built application only. This will reduce the image size significantly compared to including the entire built environments. Okay, so let's do this. So first of all, like we'll just mention that this is stage 1, build with Maven, and here what we are going to use is we are going to use this base image of Maven 3.8.1 hyphen OpenJDK 17. I will use OpenJDK 17 Slim. I will use as build. So if you want to see these images from where I am getting these images, you can just search on the Google Maven Docker images OpenJDK 17. You will be able to see all those available images. Okay, we can find out here are like many images. You can use any of this image. Okay, now this will just set the base image to this Maven one, and it will contain this OpenJDK 17, which is necessary for building the Spring Boot application. This as build is just like tag name for this stage build. Okay, and now we are going to set a work directory. How we are going to set in the Docker container, we'll just create a /app directory, and then what we are going to do is we are going to copy the pom.xml file from the host machine to the /app directory in the container. This will contain the project dependency and the build configuration. Okay, now what we are going to do, we are going to copy the all files from current directory on the host machine to the /app directory. Okay, and so this will include all the source code and the necessary files and the configuration files for building the application. All right, and then we are going to run the mvn clean package, and we'll just skip the test cases also. Skip test. Okay, and so it will just create a jar file under the target directory, and we'll skip all those test cases. Now what we are going to do is, let me just make it caps, we are going to work on the stage 2, create the final image. All right, so this one, now here we are going to use JDK we need to use. So we can use a JDK, let's see, use Eclipse Temurin we can use. Is there anything coming? Yeah, here also we need to use the Java 17 also. I'm using Java 17 because this project is specific to Java 17. You can use the Java version like based on your project. I'm using Java 17 because this application is on Java 17. Okay, so we are going to use the Alpine version of this image. Okay, so this will be in the lightweight. Okay, and now this is the one, and we need to also define a work directory inside the container to /app directory for this final image. Again, we are just creating a /app. Then we are going to copy the Spring Boot jar from the this app target directory to the build stage to the /app directory of the final image. So let's see from where we will copy. We are going to copy from the build stage. There in the app directory, we have in the app and the target, we have a jar file name as springboot-example.jar. We can see in the pom.xml our Spring Boot application file name is springboot-example. So we'll just use this. So we see the in the from the build stage and the /app and the target, it will have the Spring Boot example.jar. Okay, so we are going to use this, and we are going to copy this in the current directory. Okay, all right. Okay, maybe there is some additional space. We will just remove this, and we are going to expose the port 8080. Okay, at the runtime, so this port will be accessible. This is default port for Spring Boot applications as well. Okay, now we need to give an like command to run the Spring Boot application. We are just to give a cmd option here, java -jar and Spring Boot this application.jar. All right. Okay, this is thing for Dockerfile. Now this is done, we need to create a GitLab CI file. Okay, not the Java class. We are going to create a file .gitlab -ci.yml. For GitLab, the file name should, for CI/CD file name should always be on the .gitlab -ci.yml. Okay, that's it. And that's, now we need to what we need to basically do is we will just define some of couple of stages here. One will be the build and another will be the deploy. Okay, so for build we are going to have build job, suppose. Okay, and here this will be part of the build job, and here we'll just write commands what we are going to execute. So we'll just echo here, echo building the application. Okay, and another will be deploy job. So here we are not specifying on which machine it will run. So if we are not going to specify a tag name for a particular stage or particular job, this will be default running on the GitLab provided runners. Okay, whatever the runner is available for this project, it will pick up those. Okay, and deploy job will be the part of the stage deploy. Okay, and here we'll just mention then deploying the application, simply deploying the application. So if we run this job, it will be running like on the GitLab specific thing, GitLab specific machine or GitLab runner, you can say, where we have seen those runners. It will pick up any of this available runner which is free first. So this will try to pick up any of this runner and our jobs will run there. So by default these runners are using the Docker images to run our this CI/CD files. So it will be by default using the Ruby images. So here if I try to build our project, right, it will give us the warning that Docker command not found, because we are running the Docker inside Docker. So that's not directly possible because but this is already running on the Docker image. So inside Docker we need Docker image. So in order to do that, we will just see how to run Docker in Docker for GitLab. So there is some additional configurations we need to make for that. We'll just see enable Docker commands in your, yes, we need to see here you can use GitLab CI. Okay, here we need to use this, not this one. Yeah, we need to use this, and let's see why this is necessary also, like enable this Docker in Docker. The Docker image includes all the Docker tools and it will have all those tools. By default it is using the Ruby image. We have seen in the last video that we have created for a GitLab tutorial. Okay, so let's just add this for our complete GitLab CI. Docker in Docker we are going to use. So for all default image will be the Docker image. Docker, the services is Docker 2405 dind Docker in Docker, and we'll just log the Docker information. We are going to use this base image. Okay, so here Docker will be accessible now. So this is Docker build -t. Okay, here it is Docker build -t, and then we need to give our image name. So before that we will just log into the Docker hub, Docker login. That is just we need to give password, Docker username, and then -p $docker underscore password. So I'm using GitLab CI variables, GitLab CI/CD variables. You also need to set these things if you don't want to expose this to users, like any of the outsiders. So how to do that is you need to see this settings here. Again, in the runners you can collapse this and you can go to the variables section, and here we can see how you can, I have already defined this Docker username and password. You can just simply click on the variables and you can just select on the masked. If you don't want to show the value also, the value will be masked, it will be not visible, it will be having asterisks with those values, it will be masked. And here you can just a test variable, okay, test var I will just and then test value, okay, add variable, and we can see the variable is already added here. Okay, all right, so you can simply add your Docker username and password. So Docker username and password is nothing but my Docker Hub credentials. So you can create a own account on the Docker Hub and you can just use the username and the password credentials here. And here also you need to create a repository. If it is not created, you can just give your project name, and you can create a repository, public or private, based on your requirement. This is the simple way I have already created, so I'm gonna use that Spring Boot hyphen example. Okay, and okay, let's do this. I will just copy this. For the next step I will just copy this. Then once we log in, we are going to build this image, docker build hyphen t, and I will just give the name of my this particular repository, username slash repository. And then we are going to give some tag to this image, which is nothing, just ci commit sha. So this will have the commit sha for it will have commit sha for our current commit. It will have the details of our current commit. So whatever the commit id will be there, it will be appended here after this. Okay, and then what we are going, okay, we just forgot to add a dot which is specify from the current directory. Okay, this will build the image here. Okay, and then what we are going to do is we are going to push the image to the Docker Hub, docker push, and the same thing here. And again we can just refer this, the tag also. Okay, we just mention the tag also. That's it, docker push, and that's it. We have, it will deploy our application to the Docker Hub. Now let's move to the deploy job. We have to, okay, this is something wrong, now it's fine. And now what we need to do is this job should run on a specific runner that we have created, which is EC2 runner, EC2 hyphen runner. So this will be only running on the AWS GitLab runner that we have created on the AWS machine. Okay, now here what we are going to use is we are going to pull the image, the same image, all right, and then we are going to run this as a Docker container. Okay, so we are going to give docker run hyphen d hyphen p port 8080. We are going to expose this port, and from the Docker we will listen this on the 8080. It will map to our AWS, and internally it is, we have exposed this 8080, and we'll just name the container as Spring Boot hyphen example hyphen container. Okay, and then the name of our image. docker run -d -p, and then the port details and the name of our container and then the image. It will run the docker container with the pulled image and will map the port 8080 on the host to port 8080 in the container. All right. And what else we can do? We can just add one more condition, that it should only deploy should only happen when it is deployed to this particular branch. Okay, so that's it. Let's try to commit this and see what will happen. Deploy to AWS EC2 instance. Okay, we have committed these details and we'll try to figure out if there is any change, any error. We will try to figure those out. So where we can see in the build section, in the pipelines, we need to go, and we can see we have the two stages here, build and deploy, and these stages have a job, build job and the deploy job. First this will be triggered, then this will be triggered. Okay, let's wait for this. So here we can see we are using the docker executor with image docker 204.0.5. Otherwise it will be using the default Ruby images. Okay, so it takes like some time to start the things. So let's, I think, wait for like we can refresh also. It takes time to display all those logs actually when we run through the docker. Probably will keep refreshing. Okay, now we can see the logs as well. Yeah. So the logs are there. So internally it is downloading all the Maven dependencies for the project, and it will just create the jar file. Okay. Okay, so the build job is succeeded, and the jar file that we have created is spring boot -example and then the tag of the image. Okay, SHA is this one, and let's go to the deploy job here. So deploy job is failed basically. The command not found, is like a weird issue. We need to figure out why. Live restore enabled false, deploying the application line 1, deploying the command not found. Okay, docker info is fine. Probably I think we have mistyped it. Let's see once again. Docker pull. Okay, no, this is fine. So let's try to run this on the AWS machine. What we can do here is we can just use docker pull. Yeah, this command is working here, seems to be. Collapse multi-line command. Okay, okay, yeah, this is the problem actually. What we missed is we need to echo this because we haven't used the echo statement. That's why there are some issues. And now I think better we add one more step here, like if the container already exists, then we'll just don't deploy this. We can just add that docker rm-f, the container name. If it is already there, we'll just delete and we'll redeploy. Okay, so this is one of the change we missed, and let's commit this changes now again and we'll try to see. Okay, so let's go here and go to the pipelines again, and we'll see if again jobs are getting picked up. Yes, the job is picked up, build job. So again it will be running here. So whatever this runner we have seen here, this is GitLab provided runner. We can just cross verify once. We need to go to the CI/CD and we need to go to the runners. We have this ID, right? 1277. So we can just see here, not this one. There are many runners available, so it can be anything actually. So in the next page also there are like many runners associated for this. So this is the runner being used. Okay, and let's try to refresh this and see what is the progress now. It still seems to be in progress. Yeah, now we can see the Maven dependency has been downloaded. Okay, so yeah, this job is succeeded now. The image is pushed. And what if we want to verify if the it is correct SHA? You can go to the repository and you can go to your branch and we can see the commit ID here and we can just search it here. This is the SHA. So this is the correct SHA is being picked up. And let's go back to pipelines and let's see what is happening on the build deploy job this time. I think this time it should work properly, but we have actually stopped the runner. We need to start the runner. Actually this runner also you can start it as a service. So for that you just need to make some additional configuration. So those configuration details you can find like inside those details here. When you are creating the runner, that time only this will be visible. So let's try to create a new runner. So here you will be able to see the section here, system or user service. So we are not creating, but yeah, you can use this commands GitLab runner install. So this will be running in the background, so you don't need to start it anytime. That's it. Now we are in the deploy job and the deploy job is successful. No, again this time there is some issue. Okay, we just missed some of the configuration like hyphen name. It should be not the hyphen name. We are just make a silly mistake again actually, and we'll try to deploy it once again. So make sure you're like while writing the CI/CD you proper added the proper indentation and the proper the all those script like Linux commands, the Docker command. So we just missed the hyphen name. You can also miss that. These are the silly mistakes. You need to find out like why this is causing the issue in your failure of the pipeline. So you need to make sure. So let's just wait for again for a couple of minutes and let's see if this is working fine or not. Yeah, I think this time it will definitely work. So we'll just cross verify. So the build job is there. We'll wait for this to be completed and we'll wait in the deploy job also. Okay, so we can monitor this here as well. The build job is running. Let's wait for this to be completed. Yeah, this is running now. For each single mistake we need to wait for all those steps to be completed. So all these images will be pushed to the Docker hub. We can see here Images are being pushed with the tag a few seconds ago. If you see here, this image is being pushed. So every time the build job, the new image will be pushed. If you want to keep the name consistent, you can give a tag consistent as the latest one. So every time the image will be updated there only. So that one thing you can also you can try out. And yeah, this time the deploy job is also successful. Let's see. Yeah, error response on no such container, that's fine, and we can see the container image id is there. So let's try to see on the AWS public IP4 address and then the port 8080. No, this time also it's not working. Why it's not working? Because we have exposed the port 88 in the container, but we have not allowed from the security groups. So that is also one thing we have missed. So for that, what you need to go, to the security groups of our EC2 instance, and you need to click on the edit inbound rules, and you need to add a rule of custom TCP and then the port 8080. Okay, for this video this is 8080. You can add your own port as well, and I will allow access from anywhere, and we'll just save the rules. Okay, I think this time it will not work properly, but we need to restart the application. What we are going to do, we'll just re-trigger the deploy job, that's it, nothing else. So this will also serve our purpose. So it will delete the old container and will create a new one. That will also work. So let's see. Could not kill container since this is already cannot be killed. Okay, so probably we need to trigger one more commit. We will go to the EC2 instance and click on the public IP4 and then the port 8080. This is not accessible now. What we can do, we can just here only, if we want to, if we want to, we can recommit the things, it will work properly. But for the time being, what I will do is I will just docker ps we have couple of images. Let's see if we can delete this. No, we cannot delete this like this. Let's see. Docker delete container. Yeah, this is the one, but yeah, this is completed now. And now also we can retry this. This should work. We need to start the runner again. Yeah, this time the job is succeeded, and this time probably we'll be able to see the response on the server. Yeah, that's it. I could have like make the recommit things, but the build process takes little time, so I just want to skip those things. So what I did is I just removed the existing container here, and I just re-trigger the deploy job. That does all work, and that's wrap for today. Like you can just see how we have successfully deployed a Spring Boot application to AWS EC2 using GitLab CI. There were some issues. Those were real-time scenarios, like real-time, like developer will face this issue like multiple times. So you need to make sure like you don't make these mistakes that I have made. So I'm just creating all those things so you will be also aware like why these errors are coming and how to fix those issues. Alright, I hope this video helps you understand the importance of CI/CD and how it can make your deployment process more efficient. If you found this tutorial helpful, please like, share and subscribe to Integration Ninjas for more such content. If you have any questions or suggestions, drop them in the comment below. Thanks for watching and happy coding. Have a great day.